Your seats will begin more or less on time. There's some seats at the front here, though for some reason they're always been infected. If we leave those ones at the back empty so that latecomers don't have to disturb everybody, that would be great.
If you sit at the front here, you're able to see some of the slides with a quite small font on the back.
Yes, don't be shy. I'll do with the housekeeping first. So, those of you who may need a toilet, it's out at the left there, in front of the desk, and then on the left. There are two fire exits. There's one straight there, and there's one out through the front doors where you came in. I hope you won't be needing it, but we're surprisingly not planning any kind of fire excursions and alarms this evening. And that enables me to get to the business of the evening, which is a great pleasure to introduce Adam Whitmore from Rio Tinto. Adam is the energy and climate change policy specialist at Rio Tinto. He's had a distinguished career that has looked at climate change issues for at least 15 years, which makes him a pretty early person concerned with these things. Worked in a variety of consulting companies. He's an energy economist with a background in chemistry, which means that he understands the real world, which is a good thing in my view. And he's worked, as I say, for a variety of organisations, including bodies like London Economics. He's now with Rio Tinto, and I'm very glad to welcome him. More or less everybody's here. Very good to see you.
Thanks, Paul. And thank you everybody for coming along this evening. When I was first asked to talk about carbon pricing around the world in 45 minutes, my first thought was I was going to have to talk pretty fast. What I'm going to do is just give an overview of what's happening in carbon pricing around the world at the moment. And principally what I'm going to be doing is looking at schemes around the world along these dimensions. A series of design features which are typical of any schemes. Every carbon pricing scheme needs to make choices along these sorts of lines. And I'm going to look at how schemes around the world have chosen to respond to those challenges. There's a little disclaimer on the bottom there that these are my views, they're not Rio Tinto's views. In one or two cases I'm going to have to go off script and say things which are contradictory to official Rio Tinto views. So this is my time, these are my views, and please don't take them as official Rio Tinto policy. Now the first thing to be said is that carbon pricing in the last decade has become remarkably widespread. And this chart illustrates that. What this is it's the percentage of energy and industry CO2, so excluding other GHGs and excluding land use, in jurisdictions covered by carbon pricing. So not necessarily all of these are priced, all of the emissions in these jurisdictions are priced, but if every jurisdiction in the world had a carbon pricing scheme, this axis here would be at 100%. So for example in the EU, under half emissions are actually priced, but the whole of EU energy industry CO2 is in there. So what we see is just over a decade ago, we just had a few carbon taxes, mainly in Northern Europe. The first big step up was the introduction of the EU ETS. You then had a succession of schemes around the world, quite a few of them interestingly in North America. And then just in the last year or so, you've had schemes go live in Australia and California. The Kazakhstan scheme I don't claim to be an expert on, but I understand is starting serious trading from next year, which is actually a small step up, not one of the big ones. And then the next thing which really accounts for most of the step change is the 7 pilot emissions trading schemes being started up in China. And then 1st of January 2015 you had a South Korean scheme and probably a carbon tax in South Africa. The recent budget statement committed to that. It still has some opposition in other government departments. But it means that in really little more than a decade, which is pretty quick going, you'll have gone from really very little to almost a quarter of world energy and industry CO2 being in jurisdictions with carbon pricing. which, as I say, is quite a remarkable trend, especially if you listen to some of the mood music you sometimes hear in the press that carbon pricing is going away and it's kind of it's not taken seriously, etc. Something that is hotly debated at times is whether an ETS or carbon tax is to be preferred. And I think really that's a bit of a false dichotomy. And if you look around the world, what you find is that many schemes have elements of both in them. And so what I've done here is I've positioned each of the major schemes on a spectrum with emissions, that's meant to be pointed. Emissions trading at the far left here, and carbon taxes at the right. And you can have emissions trading scheme with the inclusion of fixed price elements. And you can also have carbon taxes with elements of credit trading. Now, first thing that's clear is the predominant model by far, and especially if you weight it by volume, is emissions trading rather than taxation at the moment. And most of these on this side are very much emissions trading schemes. So the EU ETS is pretty much pure ETS. It looks like the Beijing scheme will be the same, though there may be some elements of that which attempt to manage the price within bands, a sort of central bank type function, or possibly a cap which is to some extent hybrid between an intensity and an absolute cap. I'll talk about that more if people are interested. Again, Australia with the EU link, that is an ETS, but I've put it a little bit further across the axis here because it actually does have the first 3 years fixed price. So it's $23 for the first 3 years. They decided that actually to get the scheme up and running, they'd start with the fixed price period. Before the linkage was made with the EU, it was actually much further across because there were further fixed price elements. Specifically, there was a price floor and there was a price ceiling in the scheme, so price bands there. Very much in the sort of classical model, going back decades now in the academic literature, of trying to introduce an element of price certainty when you're faced both with uncertainty about damage costs, but also uncertainty about the cost of abatement. California and Quebec are still there. See on the next slide, or next slide with one. California has price floor and price ceilings, so they're both somewhat soft. And as such, there's actually a boundary within which the price is maintained. That gives you some of the elements of price certainty you find under a carbon tax. The Alberta scheme is a true hybrid. It's essentially an intensity-based emissions trading scheme. So you can generate credits. You have a baseline, which is 88% of your historic emissions, or your baseline emissions. And if you come under that, then you generate credits which you can sell. And if you're over that, you can buy in credits. But equally, there's a buyout of $15, and that's a fixed price. And in practice, that's, a number of companies are doing that. There is a buyout fund there. So in practice, there's a price of carbon in Alberta which is fixed. It's $15 a tonne. There's talk about changing that, specifically increasing it to 40 and also increasing the ambition of the cuts. But those are still at the proposal stage. So there, it's both an emissions trading scheme and a fixed price, effectively carbon tax. If you move on to here, you've got the proposed South African carbon tax, which is pretty much a straight carbon tax, except it will have some elements of trading because it will allow offsets under the scheme. So you can meet some of your obligations through a traded market in offsets. That's if the currently proposed form is indeed implemented. And then from the right, you've got the British Columbia carbon tax, and that is just a carbon tax. So you can see you've got really a fairly complete spectrum from one to the other. And it's by no means clear that the best policy choice will always lie at either end. And in particular, I think many of us would argue that the EU ETS model, without any form of price containment mechanism, has been shown to be problematic, at least in some respects. And I think there is much to be said for the sort of model that California has followed. Phil, I'd like to apologise for this chart, but I'll work through it. it's got a lot of lines on it. These are the price floors and ceilings. This group at the top is a group of essentially successive tranches of ceiling under the California scheme, and that's roughly where the Australian ceiling would be, depending on what the international price was. It's still technically enforced, but it's never combined because it's relative to the international carbon price. They've now went to the EU, so it's most unlikely that will ever be triggered. These are fixed prices in the sense of being floors. That's the British Columbia carbon tax, going down because this is in real terms here, and there's no escalator built into the British Columbia tax, and indeed at least one of the politicians for the forthcoming election has committed not to increase to nominal terms. And likewise, Alberta is coming down in real terms, but if that is increased, clearly that will change. And there, the blue line is the floor on the California scheme. I put in the UCL carbon price support here, which is an interesting example of trying to introduce a carbon price floor which is not coextensive with the emissions trading scheme. Similar scheme in Australia where there was a desire to put a floor on the price of international offsets, and that was proposed that would be done through a top-up. That proposal was again fallen into abeyance when the floor was discontinued as a result of the linkage with the EU ETS. But both of these, both the carbon price support and the Australian top-up scheme are attempts to put a within jurisdiction floor on a wider trading scheme. If you'll forgive me, I'll take a minute just for a sort of 2-minute rant about what a hash the UK government has made of introducing carbon price support. And I have a certain sort of personal interest in this because originally this came out of some work I did when I was acting as a consultant for DTI on the energy review back in the mid-2000s. And I had a couple of meetings with Greg Clark when he was shadow DEC secretary just before the last election, and that's how it got into the Conservative Party's policy documents. And the original idea I thought was kind of elegant in that it was a rebatable tax which would have allowed you to rebate the costs of efficiently incurred costs of purchasing EUAs against what is essentially a carbon tax. There's always an awareness that under the EU ETS, the emissions in e.g. the UK power sector were lower, they were elsewhere. There were two justifications for nonetheless doing something. Firstly, the UK has its own targets. Secondly, on a dynamic basis, this would encourage low carbon investment, which would enable tighter caps to be set under further phases of the EU ETS. I think in many ways the justification for it now is stronger because of the problems with the EU EUA price and the surplus allowances. Now estimates you see between $1.5 billion and 2 billion tonnes surplus under the EU ETS. The problem with it, it's just a tax put in by Treasury on a 2-year forecast, and as we found out, nobody can forecast what the EUA price is going to be 2 years from now. So it greatly reduces the certainty that's actually offered by the cap. And to me, that's not a desirable way to go. What we do find is prices vastly different under all of these schemes. The record for the world's highest carbon price, at least explicit carbon price, I leave aside implicit carbon prices from other policies like renewable support, is in British Columbia, which is $30 a tonne. This is in US dollars, but it's 30 Canadian dollars, but the Canadian and US dollar are very close to parity at the moment. Then Australia at the moment, because we've got a fixed price period there, is around about 23. Alberta, California, EU, and down to RGGI, Regional Greenhouse Gas Initiative in the northeastern US, which previously was at its floor price of just under $2 and has been a little above that recently. Perhaps you would talk about the timing of that. However, this is just now, this is a snapshot, this was about a week ago. It's easy to forget, but the EUA price used to be up here. It was well over $30, it was 30 euros, so over $30 at one stage. and it's traded across that range, indeed a little bit lower than that at times. So just because that's today doesn't mean you can always expect a low EU price, clearly. And the volatility of emissions trading scheme prices is one of the good reasons for putting those sorts of price bands like those. Offsets are a feature of all schemes, but they differ quite a lot in the way they're implemented. So, good, very simple idea that a ton of emissions anywhere in the world with this particular environmental problem, unlike many others, it pretty much means the same thing. And therefore a lot of support for introducing offsets of increasing cost-effective abatement. And many have suggested that that should essentially be unrestricted because a ton of avoided emissions is a ton of avoided emissions. We find in practice that almost everybody, in fact everybody in practice, has restricted them on three main dimensions. There's geography, international versus domestic. There's the type of offsets that are allowed, and also the total quantity. I can think of only one example where there was a proposal not to restrict that, which was the initial version of the Australian scheme, the CPRS, which was never actually enacted. So you can see some examples here. Australia's restricted domestic only up for the first phase up to 2015, that's the fixed price period. Alberta is only within Alberta. If you can buy offsets under the scheme I was referring to, but they're within Alberta. California is a little bit more inclusive, that you get land use offsets from elsewhere in the US. There is also a proposal for RED, i.e. tropical forestry emissions essentially, to be allowed from certain states in Mexico and Brazil, so that will take it outside of the US. But at the moment the protocols are all restricted to the US. Likely types of offsets, so the EU doesn't allow forestry offsets, this is different from California in that respect. Australia is on the contrary quite keen on what they call their carbon farming initiative, which is land use offsets. And again, REG you find both land use and methane. And then quantity, again, various different sorts of quantitative restrictions. Good question as to why. Why do people have, not only do they all have restrictions and offsets, but we find really quite different types of restrictions and degrees of restriction. And I think a lot of that has more to do with political economy than it does with pure economics. So it's notable in North America, for example, that it tends to be more restrictive to not liking international offsets, and partly that's the intellectual climate over there, but it may also have something to do with perceptions about not wishing to subsidise other economies, that sort of thing. But I think it is interesting to see just how varied offset provisions are, despite the fact we're all trying to, in principle, solve the same problem. There is some evidence that of increased coverage of sectors and gases as emission trading schemes have developed around the world, or carbon pricing schemes have developed around the world, but it's quite limited. So again, there's a simple and straightforward view that you want the most cost-effective abatement wherever it occurs, and that means that you should extend trading across as many sectors and gases as you can. But in fact, there are that's not what hasn't been done under the EU ETS, which was the first large-scale scheme. As you've seen other schemes develop, there is some evidence that people are going for wider coverage. But by no means always, and certainly not on a consistent basis. So there is some increase in coverage. So you've got transport in the California and Quebec schemes, gas distribution, which is a proxy for downstream emissions from natural gas combustion in Australia and California schemes. Likewise, methane is in the Australia scheme. Nitrous oxides and PFCs have been included in the third phase of the EU ETS. But this is by no means consistent, and it's by no means true that more recent schemes cover all sectors and all gases. And also the Chinese schemes, particularly the Beijing scheme, about which we have the most information so far, looks likely to be restricted to larger emitters, probably about the same proportion of emissions as the EU ETS, maybe a little bit more, because of the preponderance of emissions-intensive industry there, but still actually fairly restricted. And I think the reasons for this are often in some of the other sectors. You see other policies, fuel performance standards for light vehicles, for example. And then with the other gases, the MRV is very difficult often. The monitoring, reporting and verification is just intrinsically much trickier for the other gases than it is for CO2. So if you're going to monitor fugitive emissions of methane from coal mines, as they do in Australia, for example, that's just a more difficult and expensive business than monitoring CO2 emissions, which can be done on a fairly straightforward mass balance sort of a basis. So it is a trend, but it's a slow one, and it may well not be taken up with any sort of fullness. I would not expect all schemes 5 or 10 years from now covering all sectors and all gases. All countries with carbon pricing make provisions for emissions-intensive industry. Now, here I have to point for the first time to this logo in the top left, which is the logo of a large mining metals company and a major emitter. So you may think that, well, we have a bias towards suggesting that there should be lots of help for emissions-intensive industry. I merely note that even if you think this is craven capitulation by regulatory authorities to powerful vested interests, this is an observed regularity. Every scheme has, and this here is the support as a percent, and I'll come on to what that means. Roughly speaking, 90 to 95% allowances, free allocation of emissions for emissions-intensive, trade-exposed industry in carbon pricing schemes today. A couple of features of this. Firstly, this is not quite comparing like with like, because people do different things. So in Australia, it's 94.5% of industry average. In the EU, it's 100% of the best 10% of the industry, which I've, for convenience here, represented as 90%. Some of them remain flat, and some of them go down through time. Quebec's scheme is quite interesting. It has a separate threshold for combustion emissions and for industrial process emissions. So if you've got emissions which are part of the industrial process, they get 100%, and that's kept flat. On the other hand, if it's emissions from combustion, those start at 80% and come down. And the weighted average, by the way, is kind of pretty much in the pack there. The reason for that is, I think, the literal translation I think it's called incompressible emissions is what the term they use to fix. It's regarded as emissions which are part of process chemistry are much more difficult to control, and therefore they get a more generous allocation. The criteria here, again, it differs a little bit. It's almost always the same industries which feature, and the criteria are emissions intensity, so it has to be an important part of your cost base, and trade exposure, i.e. not the power sector, with a couple of exceptions. These have to be competing in price-sensitive international markets, in other words, bulk commodities. This data is for the most emissions-intensive industry. Other less emissions-intensive industry, like manufacturing and so forth, tend to get that lower levels, called 60% or something like that. The more tractable problem is the knock-on effect on electricity prices for electricity-intensive users. Now, there aren't very many of those in the UK, but there are quite a few of them in other markets around the world. And that's a trickier problem because it's additional costs on large electricity users, but they don't directly incur the costs of surrender of emissions allowances or the incidence of a carbon tax. Example of carbon tax would be South Africa. There you have a monopoly coal-based generator, Eskom, which has no incentive to do anything but pass through a carbon tax. One presumes it will. But that's not something that's directly paid by the electricity customers. They pay it indirectly as part of their electricity price. And perhaps because this is a somewhat more indirect issue, or indirect cost, there's been actually quite a variety of ways that people have come up with of dealing with this. So in the EU, it wasn't written into the directive, but financial compensation, i.e. simply money, was left to the discretion of member states, but with a cap, roughly 85%, it trends through time, of costs. Alberta, it's an intensity benchmark anyway. It's kind of built into the system that because as you generate an additional megawatt hour, you get 88% of the emissions, its impact on the marginal cost is relatively small. REGI, again, it's left at the state's discretion. Australia, instead of providing financial compensation, they provide allowances. So if you're an electricity consumer, each megawatt hour of electricity, you get a tonne of CO2, tonne because it's largely a coal-based system, to compensate you, and that's a valuable asset which you can then sell and it compensates. California is different again. There's a lump of money given to the distribution company, which is obliged therefore to make a corresponding reduction in its tariffs to adversely affected consumers. And finally, Beijing, again a coal-based power system, but it's a regulated price. What happens there is the generator is given a generous free allocation of allowances, but they're prevented from passing on any of the price and regulation, so there's no problem with a windfall gain, as we saw under the ETS. So actually, almost anything you could think of doing to actually compensate large power users for additional costs has been tried somewhere or other around the world. I'm not sure there's any best solution, but if you want to advocate for any of those solutions, you can probably point to somewhere it's been implemented. Border carbon adjustments, which I'm not, to be honest, much of a fan of in almost all circumstances, do have their place. It's not a very large place, but do have their place. And in terms of examples of implementation, you can see a few. They are scarce, but you can see a few. There are adjustments for electricity imports. So under the Beijing scheme, if you're buying imported electricity, you will need to surrender allowances for the imputed emissions from the electricity import. So it's effectively a dollar adjustment. Likewise, in California, the electricity importer must surrender allowances, of course, according to the first delivery within the state. Again, this is effectively a border adjustment. That does raise the problem in the US system where there's lots of coal and lots of gas, of shuffling around the imputed source of your imports. That's referred to as resource shuffling in the US. And there are measures in place to try and avoid that. Trying to prevent exactly sort of gaming that is one of the problems with border adjustments. And I think those rules are yet to be tested or indeed perhaps fully established. Otherwise, I'm not aware of any actual implementation of border adjustments anywhere. And again, that may well tell you something about how good an idea they are, or not in many cases. Though there have been some suggestions that they may be introduced in California for cement. And actually, cement is probably the best example of something where border adjustments, for various reasons, actually work pretty well. You know roughly how much CO2 has been emitted. It's difficult to do something about the emissions during production. It is, however, possible to substitute in end use, so you do want that price signal there. And so that one I can see potentially does have some legs. I keep coming back to China as critical in all of this. It's the world's largest emitter, and increasingly getting serious about carbon regulation. You will notice I've said almost nothing about the UNFCCC process so far. That is not an oversight. It's because everything relevant and interesting is happening, or most of the relevant and interesting stuff is happening at a regional, national, provincial level. And part of that has obviously been failure to agree or failure to align interests at the international level. One of the encouraging things is that China is, as far as I can see, getting very serious about tackling this problem. And there are two groups of reasons for that. One is factors directly related to climate change itself and emission mitigation. The other is the wider correlative policy objectives. So on the factors directly related to climate change, firstly, they are concerned about the effects of stability on climate change, particularly to do with water, and particularly to do with agriculture, two very sensitive issues. There are other things as well, extreme weather events and rising sea level, which is certainly not going to do Shanghai any favours, but those are really quite immediate and very pressing concerns. It's easier for them to do things in some respects. The costs of abatement are lower because of the emissions intensity and in particular the inefficiency of some of the infrastructure there. Also, China's own actions are enough to make a difference to the problem. They're of sufficient scale. The free rider problem is therefore very much reduced. So, to pick an example, New Zealand has an ETS, but what New Zealand does with its emissions frankly doesn't make a whole lot of difference to the world total. China, if it does something about its emissions, makes quite a large difference to the world total. And in fact, there's some interesting modelling done by MIT last year which found exactly what you expect, that China can make a large difference, and in fact, could make as much of as a full degree difference on its own to the rise in temperature, simply by reducing its own emissions. And not only its own emissions, if it acts, it provides leverage on other jurisdictions, so there's some kind of multiplier effect. However, even if you don't believe all of that is enough, there are a whole lot of other things that they're trying to do in China, which are actually very consistent with pursuing emissions reductions policy. So firstly, they're looking to move towards a more efficient, service-based, less energy-intensive growth model. Does carbon policy fit with that? Absolutely it does. Also fits with energy security, other things. So a whole load of other policy objectives, policy priorities, local air quality, huge issue at the moment, as probably all aware. But other things, energy security, costs of imported energy, reducing energy use, increasing efficiency, reducing emissions, consistent there. Though there is an issue about imported gas versus domestic coal, and how some of that plays out will depend a lot on how successful they are at developing shale in China. Shale gas. Provincial coordination is possible, and indeed it might even help smooth out some of the differences between the provinces. I'll come on to that in the next slide. And finally, fiscal objectives. China does in the longer term face a demographic challenge. It's not quite as severe as that in some other countries like Japan, but although it's not something for the present, as you can see as you move into the 2020s, increasingly simply revenue raising will be one of the attractive features of carbon pricing within China. So particularly as regards economic reform and increasing efficiency and reducing energy use, very good consistency between doing something on carbon and doing something on meeting other policy objectives. And that's why you see such a range of activity in China. There are carbon intensity targets now in the 5-year plans. There's nationwide efforts to establish measurement, reporting and verification systems. There's the 7 trial emission trading schemes, which, by the way, cover emissions with over 1.5 billion tonnes. Provinces with over 1.5 billion tonnes of emissions. That's a lot, even though it's just 7 provinces. It's a huge chunk of emissions. There are quite well-developed plans to roll that out nationally, probably within this decade. Climate change issues and adaptation are part of training in part of schools for administrators. There's public education, there's research, there's cooperation with bodies like the EU on establishing frameworks for policy and trading platforms and that kind of thing. So a vast array of things happening, all with a view to gradually stepping up action. And if you ask me what makes me optimistic, if anything, about the carbon space, this is certainly one of them. Now, people rightly point out that China is a big place, and it's very diverse, and the West is not like Shanghai. And, well, how can you have emissions trading in such a diverse country? So what this chart shows is actually GDP per capita broken down regionally in China. So this is the current or recent 2010 GDP per capita by province in China, with kind of Shanghai and Tianjin over the right-hand side here and some of the west over at the left-hand side here. And I've just extrapolated down on a very simplistic basis with GDP growth, so the same regional differentials persist. Now that's almost certainly not realistic, especially if you were in a PPP correction. You really won't find Shanghai that rich, it'll get squashed down, and some of this will probably be brought up. But the point this chart is trying to make is to compare that simple extrapolation here, just inflating up by GDP, to where China, or admittedly a relatively optimistic scenario, will be in 2030, with the EU as it was in 1990 when it first started to make commitments. As you see, there is a slightly greater dispersion of income in China between rich and poor. It's not vastly greater than in the EU, where there's a big difference between Denmark and some of Eastern Europe. So you can certainly see that there are possibilities of introducing widespread emissions trading where there are quite large income differences, and the reason you can see that is it's happened in the EU already. Furthermore, to the extent there are these differences, the use of offsets offsets or more binding caps under a national scheme actually essentially allows wealth transfer from some of the richer regions to some of the poorer regions, if that's the way they choose to go. And at the moment that's still unclear. The Beijing scheme allows for offsets, the Guangdong scheme almost certainly won't. So while I certainly would acknowledge that there's an issue here as to how you impose a national emissions trading scheme when some parts of the country are really still quite poor, I don't think it's by any means an insuperable obstacle. Now, some things I'm not saying here. I'm not trying to imply that carbon pricing is a complete policy solution in itself. And here's a fairly standard list of things that you also need to do with other things like system level effects and other sorts of marketplaces. One thing I would point out perhaps is performance standards. Just as earlier I was suggesting that there is a spectrum of possibilities between carbon taxes and an emissions trading scheme. There's usually thought to be a dichotomy between command and control regulation and trading. But in fact, you can find things in the middle, and such measures are being debated in the US, where the chances of a federal cap and trade scheme are close to zero, and carbon tax also seems like a long shot. And regulation will almost certainly by the EPA. And for existing power plant and other sectors as well, the EPA is obliged to put in place performance standards, which sounds like flexible command and control regulation. But as I understand it, there's no reason why under the relevant section of the Clean Air Act, which is section 111D, which is rarely used, so I'm told, that you should not have trading around that. So you can have a tradable emission standard. You put a performance standard in place. If you're over that, you would be able to buy from somebody who is actually outperforming your emission standard. And that begins to seem very like a sector-wide baseline and credit trading scheme, intensity-based baseline and credit trading scheme. So once again, the distinction is not necessarily absolute. That wouldn't get you all of the benefits of trading. It would probably be restricted to a fossil fuel generating plant, and it would be intensity-based. It wouldn't have a cap. But nonetheless, it's somewhere on the spectrum. It's not pure command and control, and it's not pure trading either. So conclusions. Carbon pricing is becoming more widespread. Do not believe anybody who tells you that on a global sort of basis, carbon pricing is an idea whose time has come and gone. It's growing quite rapidly. If I was to be provocative to some people in the US, I would say that you don't have a federal trading scheme in place. You might not mind being, don't have a federal carbon price in place. It's maybe okay if you don't mind being behind California, Europe and China, but you really want to find yourself behind South Africa and Kazakhstan in this area. Emissions trading is predominant, but with some use of price floors and ceilings, and desirably so in my view. If you're